Hi, welcome, Godspeed. This channel is against the Big Bang, against all the and about astronomy. So in this video, if I'm going to explain to you the entire physics in half an hour, you will listen, you understand. So I will explain to you the entire physics in half an hour. So let me do it fast. So I've told you he is mistaken. I'm connecting with Brian Schmidt. The universe is not accelerated. We cannot see the universe. It is only our galaxy, and it is static. Okay, so so I've told you he is mistaken. Gravity means to accelerate from Galileo Galilei time. Galileo Galilei made this. Two objects fall with the same acceleration, 9.8 meters per second. This is what Galileo made.
Now, it's nice to think of this toy model, but you really want to understand things in the universe with a theory. And our theory comes from Albert Einstein, widely respected as one of the greatest physicists of all time. In 1907, Albert Einstein had a revelation that acceleration due to motion and acceleration due to gravity were indistinguishable. That is, imagine you are in a box and you are on Earth and you don't know where you're at, and you feel yourself being accelerated by 9.8 meters per second squared, the gravity of Earth. Albert Einstein's thought was that you cannot tell, using any physical test, whether or not you're on Earth or in a rocket ship that's speeding up at that acceleration rate of 9.8 meters per second squared. A very simple thought, but a thought that took him 8.5 years to reconcile with mathematics.
You can throw rocks from some height and they fall in the same time, no matter the mass. You understand? So this was what Galileo said. Now it is strange, and you will ask why, but it does not matter. It doesn't matter. Brian Schmidt says that it is a force of attraction. It is not a force of attraction. It is here is a vector of 9.8, here not on Earth. Not the Earth is attracting it. It is strange to you or not, this is how you make it. You consider this a point of mass, a point, mathematical point, and you put vectors. A downward vector 9.8 meters per second. And he says wrongly, okay, that you throw up this object in the air, the gravity slows down. This demonstrates that he does not know physics very well. Does not slowing down. It is consuming the momentum of movement. So he is not knowing even good physics, okay? The rock has a momentum of movement, an kinetic energy of charge energy of movement, like mechanical work, and you throw it in the air and the rock consumes the momentum of movement, of energy, and the rate of consumption is 9.8 meters per second. Why you are tricked to do not understand this? Because 9.8 meters per second, it is indeed space over time. And how this space over time consumes energy. So this is the trick. Because the vector is always down with 9.8 meters per second. But when you put it in an equation, any property, let's say property of an object, physical property, is energy, mass, force, this kind of thing. Any property of these are connected, okay? So when you put it in the equation, this is the percentage of slowing down, of diminishing of the energy, 9.8 meters per second. When you throw this rock, it consumes with the energy, and it will stop and will fall down. So it is not okay, it is consuming energy.
So we think the universe is about 14 billion years old, but there's an extra complication. When I showed you this diagram, that line is straight. But what if gravity is slowing the universe down. We expect, by Einstein's equations and just common intuition, that gravity is going to pull on stuff. And so just like a ball that I throw up in the air and the Earth's gravity pulls and slows down, I expect all the gravity in the universe to pull on the universe and slow it down. And so this universe, you can see, is not as old as it might otherwise be. Indeed, if we went through and added a reasonable amount of gravity to the universe, instead of being 14 billion years old, might only be 9 or 10 billion years old.
So, you understand, this is first thing. Now, Galileo said that these rocks will fall at the same time. And it is not fair, you will think. It is correct to think like this, okay? Why this small body falls in the same time, this one? But it does. And Schmidt demonstrated this on the moon, and he said this word. Galileo, what do you know? Galileo was right. That Galileo said this, okay? But he did not know why. You make with rocks and you obtain this speed. 9.8 meters per second or 10 meters per second. He did not knew why exactly. He discovered it was not stupid, he knew mathematics. He discovered the Jupiter satellites, and he saw that they are moving like this, and they knew the solar system like with rotation, and he could infer some things. It was not quite stupid, okay? But let's say now Newton said this. Galileo said that it is moving 9.8 meters per second. But it is not fair, said Newton. What this differs? And he said the force differs. What does means? So the force of the impact of the table will different. The body will accelerate the same. But they were charging with 9.8 meters per second. They will charge at a mass, and they will multiply the force of the impact. You understand? So now, physics on half an hour, if you understand. So now, so if it is wrong and he does not know physics, okay, this laureate prize Nobel, or he does not know how to speak. Maybe he knows equations, but it is mal speaking, like it is different, okay? Let's say that he knows, but he speaks bad.
When I showed you this diagram, that line is straight. But what if gravity is slowing the universe down? We expect, by Einstein's equations and just common intuition, that gravity is going to pull on stuff. And so just like a ball that I throw up in the air and the Earth's gravity pulls and slows down, I expect all the gravity in the universe to pull on the universe and slow it down. And so this universe, you can see, is not as old as it might otherwise be. Indeed, if we went through and added a reasonable amount of gravity to the universe, instead of being 14 billion years old, might only be 9 or 10 billion years old.
Now, some guys were coming and they made a kinetic energy and energy of movement, mechanical work and energy of movement. This is what I think it is confused with electricity. The first energy was like power, a philosophical concept, Greek concept. And there was two kinds of electricity, like old energy, not electricity, like you understand, energy, like kinetic energy of movement and static energy, potential. Why they discover this? Because you see, when this body hits this body, it will give some energy to this, and they were making the philosophical the energy. This was how they were naming this. It is an energy that from some impulse, this object gives this object, because Galileo is not enough. Newton with force of mass is not enough to explain this phenomenon, okay? So it will give an energy and has a potential energy of resting energy depending on mass, and they're doing some calculus. So now you understand why it is wrong again. It is not pulling, the earth is not pulling and slows down. You understand that it speaks falsely. The Lord Prize Nobel, so Lord, so how can he calculated the expansion speed, accelerated speed? He doesn't understand physics correctly. Okay, so now they were known this, not Einstein. He says that Einstein, you understand now that he does not understand what Einstein. Galileo already said that the gravity is acceleration, and then energy was treated like, I believe that Einstein even did not make a big fuss on this. The laws were already given of energy and kinetic and connected by mass before Einstein. So now you understand that the earth does not pull this object. You have a vector not even in the earth. You do not have something that emits, the earth emits and like radar and comes in this object, and because in this way you will have a speed of connection. And it will be maximum of speed of light, the speed of gravity, if you be, and you will it'll be like my hand will pull down like with my hand. So you throw it with a charge energetic, there my hand is still on the rock and my hand pulls it down 9 meter per second. And if you break my arm, you escape. Like, you understand how energy is connected with gravity in this way. But they already connected this, not Einstein. Einstein did not do this. They already connecting this, because here is a vector of acceleration. It consumes momentum of movement, of speed. It consumes the momentum of movement, of speed. And it is here. In this rock, strange to you or not, it is a perpendicular vector 9.8, and you move this if you have computer graphic, you imagine. With different speeds, this acceleration, and this will always, it is the factor of consuming the momentum, if you understand. You combine the vectors, like you have a big vectors and this perpendicular one, you compound them, and you understand how it will consume the movement. Gravity consumes the movement, if you understand. This is rather connected to the energy. And now Einstein made something. If you throw this rock in the air, indeed it is connected with the speed of light, if you understand, like in this circle, mathematical circle, okay, like exactly like here. If you have this center and it is the earth, and here it is an object that it is orbiting, or it is connecting somehow. It is connecting, it is the same system somehow. It is the same system somehow. And you must have the law how it is consuming from here to here with this radius. You understand? So if Einstein made something, this connection, that's why he not connected the gravity, made the connection at the speed of light. The connection already made between energy and mass. He made the connection at the speed of light, somehow connected the electrical energy, like electron energy, with mass, if it did something. You don't understand that nothing comes through physics, only through inventions. It seems strange to you. So through inventions, you have the impression that the physics are great. The physics, it is, the Newton said correctly this. The philosophical mathematical principle of the philosophy of nature. This is how he named his book. So now the object has an energy of movement. It is consuming by a factor of acceleration. What Einstein said, he says that it is charging through movement, and the mass increases. And he calculated, let's say that he calculated how big you can accelerate an object, and the maximum of acceleration 3000 kilometers per second. It will charge this object with infinite energy. In other way, if you want to obtain the speed of light of this object will increase in mass, and you require much more energy to accelerate it. You understand? Like you understand this from a car. You consume energy. You hit the brakes. You hit the acceleration, and you increase the consumer of the engine, of the gas. So it is a consumption of energy that produces increase of velocity of acceleration. So, and it is matched with the speed of light, you understand? So Einstein connected with the speed of light, energy and mass, like to make a bridge between electricity and this. In this way you can say that the object is really bound by the earth with electrical energy, like electron energy, not like kinetic and potential energy, of potential of giving some quantity of movement, of mechanical work. You understand? Or energy movement, or energy of movement. So why this is false what he says? Because if a galaxy will accelerate, it will consume energy. Where is the consumption of energy of galaxy? Or it will increase in mass. You understand? So he does not know physics. And Einstein maybe did not many things. Because if you know this already were kinetic energy and movement of energy. And this is the thing that I want to tell you. Maybe it is wrong. The energy is not electrical energy. And this is some conceptual philosophical mistake. And I will going to tell you this. The laws are not connected. And they not did bigger of us. Force equal a mass of acceleration. This is the only thing Newton said. What is this? Is a big fuss. Force equal mass of acceleration. And you put this on what we know. Circle of movement, rectilinear uniform. And this is mathematical application of these things. And you have electrical energy, like kinetic electric energy, like this of impact. You give movement, a mechanical movement to an object, okay? And you have consumption with acceleration. It is consuming the energy. If you understand, it is not slowing down. It is consuming the energy of movement.
When I showed you this diagram, that line is straight. But what if gravity is slowing the universe down? We expect, by Einstein's equations and just common intuition, that gravity is going to pull on stuff. And so just like a ball that I throw up in the air and the Earth's gravity pulls and slows down, I expect all the gravity in the universe to pull on the universe and slow it down. And so this universe, you can see, is not as old as it might otherwise be. Indeed, if we went through and added a reasonable amount of gravity to the universe, instead of being 14 billion years old, might only be 9 or 10 billion years old.
Like if it is decelerated because in the first place the vector is here, downwards, okay? So nothing attracts, and he speaks. And you add what? If you add what? Some gravity. Where do you add it?
But it also turns out mathematically the universe wouldn't sit still even with the addition of this stuff. So the idea of this stuff is you'd add some of it to counteract gravity, because this stuff causes gravity to push rather than pull. And we're going to come back to this later on.
To attract. You expect that he add gravity, he attract. Because it's meter per second. I've told you in my previous video. It's meters per second. This is what acceleration is. And he says that Einstein says this, but this Galileo says not Einstein. And Einstein explains to you like with a rocket. And you must understand another difference between speed and acceleration. This is a problem. Acceleration is increasing. 1 meters, 1.1, 1.2, 1.3, okay? And the speed is constant. Like now, on this axis has 2 meters per second. Not square, you understand? And this is a big place for mistakes between speed and acceleration. When you accelerate a car, you consume energy. You charge the car with something, with mass. The charging of mass is unperceivable. But when you approach the speed of light, it is showing. Because the graph stops at, or in other way, goes to infinity. So in other way, you cannot have a mass if you have speed of light. So this is this proves that even black holes are false. So I explained to you all the physics fast. The Galileo said that they fall in the same time, 10 meters per second. Doesn't matter how. He did not knew. And Newton says this in his book in the beginning. Says the gravity does not put the moon and the earth in orbit. It is a prior explanation. He says in the beginning of his book. And this is what falsifies that with attraction, that they do not knew, like Laplace guy that says that it gathers. Nothing gathers and attracts, if you understand, because it is accelerated meters per second. This is how popular that do not understand physics falsify. Like Laplace is saying that the clouds are gathering, making stars, clouds of gas, with gravity. And this Lord Nobel Prize winner, you understand they give Nobel Prizes on who is illogical. Says that you add somehow gravity to the universe and the audacity to lie that you can calculate from light mass. The audacity to dare to say that you can calculate the mass of the universe and the age. So you understand physics on short. There is an energy of movement and it is consumed. How not it does, okay? And I can explain to you philosophically, but the physics guy do not know much more bigger deal than this, okay? So you understand that it is not attraction, it is in a way consuming with the rate of meter per second, because any property of space is space-time property. It is in this space-time. So the space-time influences the energy, the space-time influences the mass. So being an accelerated vector from here, it is compounding all the vectors, energy and mass vector. And this is how it comports. It diminishes the energy of kinetic energy from, let's say, 2 energy, 1.999, 1.989, it decreases the energy. You understand? And decreasing the energy, it will charge momentum, any other thing, and it will decreasing the momentum like this. And there are two vectors, different vectors. When you took this rock in the air, it is a vector like this one and an always vector like this one, okay? And this 9.8 meters per second is diminishing the energy and the movement of kinetic energy until it stops, and then the same vector accelerates and charge the object again. You understand? It is in this way diminishing the energy, and in this way it's charging in again to bring it back again to the earth. You cannot observe the charge, the mass stays the same, because the charging said I think this said Einstein. It is charging very unperceivable. The charge of energy and mass is unperceivable. Not at the speed of light. At any speed, the charging is given by Einstein. The charge on mass, due to the acceleration, it is getting, but you do not observe this. It is, you understand that this function to be equal. It is losing energy, kinetic energy like this. It stops at zeros and accelerates again towards. And the vector is constantly perpendicular here, not at the earth, here on the rock, not on earth. Though I explain to you physics, if you understand, in half an hour. You understand? So, what accelerates the universe? Because when you have a constant speed of the horse, of the car or something, it's a constant speed. When you accelerate it, you must give energy to the system and you increase the mass, or you lose the energy. Like in a, you understand? So, what gives the energy of acceleration? The universe is not accelerating. I've explained physics in half an hour. So it is wrong. And we cannot see the universe. You are tricked, okay? You are tricked. The galaxy has like metallic objects like this, put in matter at the border of our galaxy, and they are stars, they are not galaxies. Maybe there are some galaxies, but we do not know them. We can only see 26 billion kilometers, and the law of the binocular and lunette demonstrate that you cannot see from a point just to another point. I demonstrate to you physics, and it is static. If you do not understand, Einstein did not knew, it is static and we see only this galaxy. Let's see what is beyond this galaxy. Let's go at the border of galaxy. It is possible. Because there are only 26 billion kilometers and there are stars like this even, small. Let's see what it is. But do not lie that galaxy are. Let's see what it is there. I explain to you physics. I'm not crazy, you understand? When you go from this center and this center, you must lose something when this object will rotate. If you stay on this plaque, you must lose something and gain something trigonometrically in a circle. In this way, this body is bound to the earth. Like you consider the earth in the middle here and the rock at this circle, exterior circle, and you have two circles. The circle that it is the circle of this rock and the circle at the earth. And somehow the rock with the earth is bound, but we do not know how. And I believe that it is electromechanical bound. If Einstein was correct, it is indeed some comparison between energy like old energy, kinetic energy, and electron energy. So the field is electric energy and it is charging and discharging like this. And the speed of light, it is something that will balance this. How much energy and mass will gain this at any acceleration, not the speed of light. But it is saying more that you cannot go beyond that speed with an object of mass, because it will increase the infinite energy. And this way, a black hole does not exist, because it will have to have, if it has only a small mass, it will have to have infinite energy to burn light, if you understand. Okay, goodbye. All the physics in half hour, you understand. The universe is not expanding. Goodbye, God bless.